All right. So today I'm gonna show you guys something about something called Codemods, or refactoring JavaScript using JavaScript. Let's see. So I'm a software engineer at Reaktor Amsterdam, where a lot of very smart people work that know stuff about these things and like a lot smarter than I am, maybe even. Who will know? So during my day, I'm mainly writing Node.js, React, and some TypeScript apps for clients. And during the after work, I'm usually tinkering with some compilers or related stuff. Mainly stuff that's not really useful for production yet. There's also my GitHub account. This presentation is on there if you want to reread something. So yeah, let's dive straight in. So what are Codemods? Codemods are, I think it's a term kind of coined by Facebook maybe. It's a bit vague, but they're also called program transformations. So basically, they are programs that take another program as their inputs and produce another program. So it's a form of meta-programming where you try to automatize your workflow by automatically either programming a complete program or refactoring an existing one. So since they're automatized, they can be applied to your entire code base, which is pretty useful if you want to do huge refactoring. And how they work internally is that they modify the program using the abstract syntax tree. A bit more on that later. So how do typical refactorings look like, depending on your IDE maybe? But usually it goes a bit like changing a function name or a variable name, or maybe even like the order of functions. And you can get pretty far with a simple find and replace functionality. Some IDEs, of course, support some automatic refactoring as well. And you can get pretty far. Maybe you want to even use some regular expressions to do the job for you. Yeah, it gets you pretty far. But then there are some issues with that. Since you're treating your program as text, you will hit some obvious limitations that you cannot really distinguish the semantical meaning of your program. For example, here we see the name foo being used 4 times as either an import from 2 different modules, a property, an object, and a string, which is like a completely different type. And it's really hard to understand which of these you might want to update. Again, maybe you can get away with some regular expressions. Some IDEs might be smart enough to infer some stuff, but in the end, you're limited by working with text. Another example of a refactoring you might want to do. I hope people are a bit familiar with React, although it's not really specific to it. A common pattern that happens in a React component is that you want to bind a method in the constructor, and as a component grows, you might have a huge list of bindings. And another way to do this is using arrow functions that are automatically already bound, and using a class property if your language supports it, like if you use Babel or something, which makes things a little bit simpler. This you probably cannot really do anymore with a find and replace, or you end up writing regular expressions for half a year, and you'll probably not really get somewhere even close to this. And especially if you have a huge code base where you want to apply this transformation to. So the key to doing these transformations is modifying the program instead of the textual representation of the program. So how can you look at a program other than the source code? There's a thing called the abstract syntax tree. People might be familiar with it to some extent. But basically, what it comes down to is that it's the representation of your application inside of the computer after parsing. And I give a bit of a example of how that might look like, leaving away a lot of nodes because these things are pretty verbose usually and contain a lot of information about your program. So what you can see here is a class with a constructor and a method, and they will be represented by a node called a class declaration, and inside of that node there will be properties like the name, the classes that will extend, all that sort of stuff. inside of that class declaration, you will have two methods defined. Inside of those methods, you will have a number of expressions like that make up the body of the method, and so on and so on. So you can go like pretty deep, and there's lots more information that I will show in a bit. So how do you make sense of all of this? There is a tool, AST Explorer.net, that helps you explore abstract syntax trees. So let me switch over. I'll load this locally just to be sure. So let's turn this off for now. So here you can see, like on the left side, any program basically that you want. This tool like allows you to parse it with different parsers. They might all. Yes, that's a good point. Better. So this allows you to like use a different, some different like parsers. They will all have a little bit of a different syntax tree. You see stuff like flow here as well. So they have some different abilities. And what they do is show you live representation of the syntax tree behind it. So this is pretty much what any like parser will get as a result. So what you can do is pretty much like hover over elements, and it will show you the corresponding nodes in the abstract syntax tree. And as you can see, it's a pretty verbose object. We can actually hide some data here. But in the end, like basically the further down you go, the further down in a leaf you get. So this is basically a tool that you will probably need if you start making stuff that I'm going to talk about in a bit, because there's no way you're going to remember all of this by heart, pretty much. So what can we do with this information? So we have this like huge tree, which is annotated with a lot of extra information that you, probably half of it you don't really care about. So what can we effectively do with this information? First, let's look at some tools that you probably already use or to some extent might use in your projects that already use like ASTs to function properly. So first one would be something like ESLint or any linter really. How they work like essentially is that they will parse the program that you're giving it to it, and using the AST it will try to read all the information and discover some patterns that you might want to give warnings for or errors or however you set it up. So basically just reading it to understand the semantics of your code and not necessarily like the specific like names for declarations that you use or anything related to the text of your program. One step further, I would say, would be something like Prettier. It does a bit of a modification in a way that it reads the abstract syntax tree from your program, so it understands what it needs to do, and pretty much like recompiles it to JavaScript, ignoring all the white space information that you were using before and formatting it in a different way. Last one will be Babel, pretty popular module by now, which pretty much like transforms the AST as well before reprinting it, so that you can use ES6 features and have them run in the ES5 environment. Obviously, there will be like a lot of other transpilers like TypeScript, all these things, they work in a similar fashion. So one other tool that I want to look more into today would be JS Codeshift. So JS Codeshift is a tool developed by Facebook that is pretty much an AST transformation tool. It's a bit similar to what Babel does, but exposing the way that you can transform your application. It's essentially a wrap around a module called Recasts, which is also an AST transformation tool, but it's a little bit hard to use if you're new to this sort of stuff, and they don't have the same sort of like helper methods that JS Codeshift will provide. Facebook uses this in practice to update their React APIs. Could be that you've already used this at some point when upgrading to a newer version of React. Basically allows you to like upgrade your whole code to be compatible with new API changes. So JS Codeshift works with files called transformations. You basically write a function that receives a file as an input, You can parse it in some way. There's some convenience methods you see there. You get passed in JS Codeshift module itself, and you will get an abstract syntax tree roots in this case. What you can do is like analyze it, transform nodes in the tree, rearrange it however you like, and then you basically call to source to output the updated source code. So I want to step back one bit to discuss a bit what the use case was for me personally. So I did some work at a client, still am actually, where there's a code base of like 100,000 lines of code. We have like more or less 50 developers working there at the time. Now probably a lot more, maybe 100-ish. 20 merges per day, daily deployments. So pretty fast-paced environment. A lot of time pressure as well. So pretty much every team that was working on the same code base will do stuff in a little bit of different way. And well, you might understand that it can get a bit messy in that way. So I want to show a fairly simple use case that we try to get into, and that is changing basically the code you see on top to the code that you see on the bottom. So in React, using a state declaration and a constructor can be a little bit like we can discuss about if it's simpler or not, but at least we want to do like standardize the way how we're setting the initial states to use a class property instead. So this was something that was like done kind of like 50-50 in the code base, and wanted to standardize it. And with the sort of code base we had, it was not really an option to go one by one through every file. So we looked into how to do this automatically. So this might look a little bit intimidating, but this is pretty much the entire function that will do the transformation that I just showed you. I hope you agree that it's not as large as you might assume. So what this in essence does, I can step through it like more or less one by one, or give at least a general overview. You get access to the abstract syntax tree, which is called root here. And JS Codeshift allows you to filter with a function called find, and returns you a collection of all the nodes that match this description. So first you want to like probably find all the classes in a file. Next you can get all of the method definitions inside of that class, or inside of every class, I have to say, filtering specifically for constructors. And inside of those constructors, you want to find assignments expressions, again, filtering to specifically find all the assignments to this.state. Don't worry too much about the syntax here. And then once we found all of these like state assignments, we can go over each of them, like you can see here, and get to know the initial states, which is a part of the tree as well. And next, what JS Codeshift exposes are a couple of builders for nodes. This is a bit similar to building elements in the DOM in the front end. So what you can do is create a new class property, use the name for it, which is the state in this case, and use the initial state as the value. Other than that, you pretty much have to find where you want to insert it. So that will be in the class body at the top. And last but not least, like remove the original state assignment. So this will be done for every state assignment in the constructor in a class declaration in the file that it receives. And in a usual context, you would run this against your entire code base. So we actually did run this, and it's more or less what we wanted. We were able to like move out these states to a class property, but there was something unexpected happening there as well, because we forgot to clean up constructors when they're empty, which was a bit messy. So, of course, what we ended up was doing more transformations. So, in these sort of cases, you could, of course, like extend the original one to allow a bit more, to allow more cleaning up, so adding more code to it. But it's quite nice to compose multiple transforms together, especially kind of generic ones, like cleaning up a constructor that's empty. That's something that might happen with a lot of other transformations. So it's pretty much something you can always do at the end to do a final cleanup. So I want to show you quickly how to do this interactively, because it's quite hard to get into at first. And again, we can use AST Explorer for this. So here we can enable also the transforms, and there's a few options, and we'll pick Kersjes Codeshift. And actually need to use the correct parser for that. So there's a default transformer being written here that, as you can see, kind of like mirrors all of the identifiers, which is something you might want to do sometime. Today, maybe that's not the best idea. So what we want to do is, just remove all of this for now. So we have here basically an identity transformation that returns the same stuff, and I will actually use the result that we had in the output. So this is pretty much what we ended up with, an empty constructor, and applying a identity transformation result in the same. That might make sense. So the way that you can use AST Explorer is to pretty much like live edit the file and feature some auto-completion, which is pretty nice. So we can start finding all the class declarations here. And as a sort of a debugging option, you can try to just remove it. That did not work as I hoped. That's true. Thank you. So this is of course not what you want, so we can do a little bit more filtering. Inside of this we will find the method definition, and it will remove it, and this is pretty much what we want. Of course this is not entirely correct, because if there would be any other class here that in the constructor does something else, it will also remove this. So we have to go a little bit deeper and filter out all of the method definitions that actually don't contain anything. Again, this might be like a point where you're not sure how to filter it, and the way you can again do this is like selecting parts in your codes and kind of like understanding in the syntax tree what is the element that we're looking for. And we can pretty much see that there is, in this constructor, there is a block statement with a body of an empty array. So as we can see here, the body of the other components will have some expressions in there. So we can simply filter on this collection as well, and this will have the method definition. And what we want to do is, from this method definition, find again the body declaration. No. That's not what I meant. Block statement. And of that block statement, we want to get the body. And this is a little bit confusing since these are actually nodes that you're representing, so we need to get the value. And we want to check if the length of that is empty. Well, of course. Okay, so here you see that like indeed like the constructor without any body inside is empty and is removed, and the other one is left untouched. So this is basically a way that you can more or less interactively try to write Codemods. The idea would be that you add some extra examples on your inputs to make sure that you're not missing any edge cases. We are actually missing a lot of edge cases here, since, for example, this might be a super call and can still be removed completely. So we have to apply some more filtering to detect that you want to have an empty one or a body with only a supercall. It can get pretty complicated actually at that point. So at some point we just decided to like call it a day and try to apply the transformation on the repository, which we did. Kind of kept our fingers crossed of not breaking anything in the project, and hope that our automated tests would like catch any issues that we had. So in the end, we see like we changed like 60 files with this. Not too many like insertions or deletions, but keep in mind that this Codemods would scan around 2,000 files automatically, and we're pretty much guaranteed that the outcome is correct. So another thing that we kind of did to make sure that everything was fine was do a quick diff check on the output. You will end up seeing a lot of edge cases that kind of break your code or leave some constructors like inside that should have been removed. And I think a good approach here is to not try to make a perfect transformation, but at least use it as a way to assist your refactoring. So edge cases you can catch and manually fix. But for the like 80% of your code, you'll probably find a good transformation at a pretty quick stage. So when doing these kind of things, like there are a couple of pain points that we discovered. First of all, documentation around anything related to like parsing or compiling is super scarce. Like there's not a lot of like information available in a, I would say, accessible format. If you go into discussions on like how Babel works internally, it gets pretty like sophisticated pretty quickly and might put people off quite quickly. So on top of that, like the JS Codeshift API is a little bit confusing since they try to like help you out with some extra abstraction layers. You're actually working with the JS Codeshift nodes. Underneath there, you have some nodes called path nodes, and underneath there, you have actually the actual AST nodes that Recast is like providing you. So you will get stuck a little time, like from time to time, trying to understand what object you're modifying. Luckily, like tools like AST Explorer help a lot with this. Like I showed, like there's autocompletion, this sort of stuff that will help you discover your issues quite quickly if you're willing to put some effort in it as a sort of initial learning curve. Another pain point is that JavaScript in general is like a quite messy language when it comes to syntax. There's a lot of AST node types available. Just think of the many ways of like declaring a function. You have, like simply put, you have like a function declaration. You can have like arrow functions, and depending on your parser, like these might be two different nodes, or they might be the same nodes type but with some extra properties. So you need to like be aware of like the fact there's a lot of edge cases, and trying to find all the function definitions might actually skip all of the arrow function definitions, for example. So you will have to like try to find some edge cases and see what works for you. And like I said before, I think a good idea is in general to focus on the large part of your code. Like don't try to apply it in a way that Facebook does. Facebook tries to give a tool that will work for everyone worldwide to upgrade to a new version of React. They have probably a little bit more time and resources to spend than most of us here do. And they also have like a way bigger like audience that they need to please. So they have, of course, like a bit of a different like incentive to make these modifications. But for most applications, I think it's fine if you focus on the large parts. It will always get better than it was before, in essence. And just like use it as a tool to help you refactor rather than something that will magically fix all your codes. So considering these pain points, like what do you get in return? There's a bit of a steep learning curve, but there is like a lot to gain here. First, there's a bit of a wow factor. You might be the only person in the company that can actually like fix that small thing that you have been working on for like months, or like go through like 2,000 files within a day and not taking like a couple of weeks to refactor all the components or files in your code base. If you're the only person in your company or at a client, even better maybe, that's a huge plus to me at least already. So another kind of an obvious one is that you can actually update function interfaces without having to worry about everything breaking. You might have like a lot of tests in place, but still, like trying to update a function that's used all over the place is really hard, and for a lot of people that might be a reason to just like postpone it indefinitely. In our case, for example, we had some functions that had to do with translating strings. That's used all over the place in an average website. If you want to rearrange the arguments, even that will already be like a big challenge usually. If you want to change using a React component into a normal function call, that's almost an impossible task, and you will need like weeks of time for that, which leaves you in the which can leave you in an unfortunate position where you have to quit doing your refactoring halfway, and you end up with like, well, an even messier code base than before. So basically, ensuring that like refactoring and improving your functions is not anymore like a big overhead to you. Like you can actually postpone a lot of design decisions. I see in a lot of cases that we take weeks and weeks of discussing how to shape a certain API or function or like service or whatever, and we spend a lot of time on it because it has to be perfect from the start. Because once we implement it and it's being used, we cannot change it anymore, or at least will be too like hard to change. If you use this as a tool and you get like a bit comfortable with it, this might actually not be an overhead anymore. And you can actually take it upon you to go and change all of these things and make everyone's life a bit better. Right, I will not get deeper into this today. I will leave you with a couple of resources that are interesting if you want to get into this. So, like I said before, AST Explorer is a very, very useful resource to understand how ASTs works in general. If you ever have the ambition to write Babel transformations, linter rules, or indeed do code modifications like this, this will be a tool that you will need pretty much. Other than that, like I can really recommend using something like Codeshift if you want to do transformations. And here are two repositories online, one for React specifically, the other one for JavaScript, that have a lot of Codemods inside of them. They can be super useful as just a consumer if you don't feel like writing it yourself, or you can of course use them as examples to try something out yourself. And lastly, was already mentioned, we're recruiting, so if you want to meet people who know a lot about this stuff, more than I do even, you can always like reach out to us after the talks and see what we can do. Thank you.